Good afternoon, everyone. My name is Pardis Bozorgi. I'm a faculty member in the School of Building Construction in the College of Design. So what I want to talk to you about is integration and how sustainability follows integration. The notion of sustainability in the built environment refers to designing and building and operating a built environment that is socially fulfilling, economically viable, and environmentally friendly throughout the entire project lifecycle. To achieve a sustainable building, there is not just one target that we need to meet. There are many. Within each of the three pillars, there are many targets that need to be met. So let me give you an example. For example, in the social pillar, to fulfill the health and well-being target, we must consider not just the health and well-being of the users, but also the laborers in the construction field. To have a building that satisfies its intended function and culture, we must seek input from the building users. And to have building systems that perform at the highest performance, we need to seek input from the engineers and also from the building operator. So as you can see, achieving different aspects of social pillar requires input, insight, and knowledge from so many different individuals and groups. To achieve economic sustainability, a system view knowledge and approach is needed to not just consider the initial design and construction cost of the project, but also the life cycle cost. We must also consider the supply chain, resource management, just to name a few. Now let's focus on environmental pillar, and there are many different aspects to environmental pillar, which basically concerns with preserving the natural state of the environment. Clean air, clean water, natural habitat, flora, fauna, and basically to achieve environmental sustainability targets, we need input from environmental engineers who have expertise in all these domains. So I encourage you to look at the agenda for this sustainability showcase, and you will notice that each of the presentations here focuses on one aspect of sustainability which within each of these three pillars. The academic research specializations basically mirror the industry professional specializations. The holistic knowledge and expertise of sustainability resides within so many different professionals with complementary expertise. I'm saying that because I want to emphasize that we can achieve sustainability, true sustainability, only when we have a holistic and balanced approach to fulfilling all three pillars of sustainability, and not just one pillar and not just one practice. And to do that, we can only achieve that through integration. Therefore, I would say sustainability follows integration. According to the United Nations 2030 Agenda for Sustainable Development, the integrated and interrelated nature of sustainability challenge only calls for integrated solutions to call into consideration all three pillars through a balanced approach. It is only through establishing integrated organization, integrated contract, trust building that we can have integrated teams who can deliver integrated knowledge and design and deliver integrated solution to achieve sustainability goals. Respectively, my research and teaching at Georgia Tech targets three intertwined tracks that enable integrated approaches to sustainability. I have focused my research in three areas. Number one, integrating project delivery contracts and trust building mechanisms. Basically, project delivery methods like IPD, which is a new emerging approach, stands for integrated project delivery. Number 2, integrating technologies for creating and operating a smart built environment. I have done research and taught courses in building information modeling, Internet of Things. And number 3, a system for forecasting life cycle cost analysis using machine learning on historical cost data. This is the research that my last PhD student did. We basically collected all historical data on all Georgia Tech buildings, and we applied machine learning, and we used the building information model of these buildings to, as input into design and construction criteria. So using this machine learning technique and this historical data, our system is able to forecast the life cycle cost of buildings, of future buildings. So if Georgia Tech Facilities wants to build a new building, they actually can refer to historical cost data and apply our life cycle cost system to forecast not just the initial design and construction cost, but the life cycle cost. So these are the 3 areas that I have been investing. And if you feel that there is a fit with what you are doing, please reach out. I'd be happy to collaborate. Thank you.